Allow me to introduce the next speaker. This is Harini Anand from PES University, a CSE undergrad and a Google Calculax mentee interested in computational cognition, and a developer intern at Niramai Health Analytics, and a research intern at the Indian Institute of Technology, Hyderabad. Previously worked on building cognitive tools for reducing the onset of dementia as a student entrepreneur, a Harvard WE Tech Fellow, and a high impact APAC ambassador for women in data science. Please welcome Harini Anand.
Am I audible? I think I am.
I'm just going to introduce your topic very briefly.
Okay, actually.
So she's going to be talking about a novel strategy for predicting Bitcoin prices by merging sentiment analysis from social media forums such as Twitter and Reddit along with LSTMs in this presentation. So the public opinion is quantified through sentiment analysis by computing compound scores for social media posts, particularly tweets, thus illuminating the prevailing sentiment around Bitcoin. So finance is a interesting topic to myself, so I'm looking forward to this talk as well.
That kind of introduction. And good afternoon, everybody. Before we begin, just to wash off the lunch jitters, can we have a huge round of applause for the team that's organizing the conference? They've done a kick-ass job so far. Radhika and Anusha and everybody. So, it's super great. I'm super grateful to be here, and I have imposter syndrome raging in me right now because I'm honored to be the youngest speaker for the conference. And any college students here? Can I see a show of hands? Okay, awesome. So I hope apart from the research that I'm going to be talking about, you're able to also take away the fact that, you're never too young to do stuff, and just don't self-reject because, anybody can sort of optimize on any opportunity you get as long as you have the courage to do so, as Arpita ma'am mentioned in the morning. So my research essentially started off based on an elective subject, deep learning, that I was learning. And I figured that the field of crypto and the field of finance was something that was very interesting and also booming, right? Yep. So that's how I got into figuring out that I want to make a paper out of this, because there was lots of research scopes, a lot of bottlenecks that I wanted to explore. And in today's presentation, I'll be talking about the introduction, the problem statement, the objective of the paper, what's the current existing work, the proposed approach that I have, and the results, and also the future bottlenecks, right? The future scope that's present for maybe other interested students or researchers to look into. So, give my intro. The introduction of the concept. So we know that social media platforms such as Twitter, now X, and Reddit are, very important because they are these podiums and venues for expression of public opinion of various topics. And this public opinion greatly affects things such as Bitcoin prices or other cryptocurrencies, right? So whenever there's a positive discussion, the prices are inflating. And whenever there's a negative discussion, the prices incrementally decrease. And the vast amount of user-generated data on these kind of platforms were an extensively gold mine of sorts in terms of data, right? And they were very much potentially valuable for offering different insights into the market sentiment. Now, sentiment analysis, as we saw in the Kahoot quiz, right? I'm sure since most of you all got the answers right, you already know what it is. But just to sort of brush up, it's a technique that helps analyze textual data and understand the emotion between and behind the text. And using this concept for gauging the public opinion and for predicting market trends, as well as using an architecture such as the long short-term memory networks. You might be wondering why, right? Since there's so many new models out there, like LLMs are the rage and Gen AI, why are we looking at LSTMs, which are so predominantly old? It's mainly because of its USP, which is to capture long-term dependencies in sequential data. Bitcoin prices or any financial data is highly volatile in nature. So it does not have a stability of sorts. So to be able to capture that quick rise and fall, you need an architecture that can have encoders and other sort of network architecture features that help you capture that when you're combining it with sentiment analysis. So the problem statement, we understood that there's sentiment analysis and there's a forum for capturing this. And we also know that there's something called Bitcoin prices, right? Or in general, cryptocurrency. So what can you sort of build out of this? What is the problem that we're targeting? As I mentioned, the highly volatile nature is one place which you could look into, which is a challenging task because it's not predictable at all, and also capturing the rapid fluctuations which are driven by the public sentiment. So these are some of the points that are used for making the problem statement, which helps us understand the research gaps. So whenever you're crafting a research paper, you look into what's the problem that you can dive into and sort of build a solution out of it, right? So simplistic sentiment measures. Those who worked with sentiment analysis already know that there's a lot of different techniques out there. The techniques that I've used, I will come to in a bit, but the current things in the market were not leveraging that. They were very simplified. They weren't compounding multiple factors, which led to a lot of false negatives and false positives as well. So that was one research gap. The other one was using static data. So when your prices are volatile, you would obviously expect that your data that you're using should also, mirror that. But the current data sets were very static in nature. That is the ones that are available on Kaggle or other platforms, and that affected the accuracies. So the objective of the paper was to evaluate whether the inclusion of sentiment analysis of data can improve the performance of LSTM networks and also provide valuable insights for investors and other people who are interested in investing these kind of currencies to sort of diversify the portfolio, right? Bitcoin has its own advantages where it has protection against inflation, it's decentralized and so on. And we also wanted to measure the performance metrics so that if there's actually any use of using and going through the effort of putting in, finding data that's volatile, that's not static, into using architectures that are catering to that, if all of that has any performance advantages. So some of the literature survey that I did was pretty extensive, but these are the top 3 papers, which basically confirmed that LSTMs performed better than the other architectures such as RNNs or ARIMAs and things like that. So this was a concrete basis for us to sort of proceed with this approach. The key takeaways from the literature survey also included the fact that using compound sentiment scores helped refine sentiment analysis, demonstration of using this in prices and other financial data helps a user understand the complex background that is involved. Coming to the data, which is one of my favorite parts to talk about because I manually extracted data for this using APIs and other such tools when it was possible. Right now with Twitter, you can't do that because now it's X and there's a couple of regulations. But back then, when I was able to do this, the time frame for the data was from between 2018 to 2023. And these were the sources and these were the features. So everyone here who's into data science knows the importance of having an abundant feature base for you to perform any sort of analysis. So we had all of these features. And we also had post information. So not only about the user, but also the contents of the post, right? The date, the context, the hashtags, the source, and so on and so forth, and how often it was retweeted. So this was basically the purpose of this was to get insights into the public opinion and the market trends. Coming to part 2 of the data, which was about the Bitcoin prices. So there's 2 pillars. One is about the sentiment and one is about the prices. So coming to the prices, we had information on the trading session, the opening price, the closing price, the high, low, and all of those various features, which helped us understand the liquidity of the Bitcoin market and the price movements. The proposed approach. So this is a high-level overview of what I've conducted. So we obviously scraped data in terms of the 2 pillars, prices and tweets, pre-processed and performed feature engineering because there was a bunch of it. We had to focus on what was actually helping us with our analysis. And then we had the sentiment analysis of the technique called the VADER analysis, which was used to calculate the compound scores. We then put that into an LSTM model to predict Bitcoin prices. And then we had our final prices with the sentiment score. So the results, which is, of course, the favorite part of any research, right? What was the results and how did it look like? So a lot of extensive data analysis was performed on this because not only is the time frame a huge amount of period, but it is also something that helps you understand the importance of this. Finance and healthcare especially are 2 areas where you need a rigorous data analysis backing so you can validate your research. So this is a joint plot that shows the kernel density of the sentiment scores. You can see on the x-axis, we have the VADER positioning scores, and on the positive scores, and then on the y, we have the negative scores. So you see most of it, it's clustered down, which in a pie chart, you can understand that most of the tweets were neutral, neither positive nor negative. They were neutral. So how do you proceed with this? You then get into the second pillar of the data, which is the Bitcoin prices. So this has been an analysis of the stock analysis chart. And you can see there are various parameters such as the open price, the close price, the high and low price. And all of them have a increasing trend as observed over the period of, the months over the year of 2017. This was done for every year. For every year across all the months, we analyze these parameters. And this is, again, a month-wise high and low stock price analysis where you see across each month what is the trend. Similarly, for another year, we have the open and close price, and we see how they're correlated and how they keep changing, which highlights my point of volatility of such data. So this is a graph that sort of explains over the year of 2021. So we looked at 2017, which was an incremental growth. And here you can see it's not so incremental. It's so much more non-uniform. And this helps us understand how you're going to use it to consider or predict these prices over a period of years. So as you can see, it had a downfall, and then we can see an upward growth, and then it sort of stabilizes towards the end. And we have a stock analysis chart of this across another year, which is 2022. And finally, we have the results of across the years. So from 2015 to 2022, what are the prices and what are the parameters that have ranged and how have they performed? So you can see a stagnant growth up till 2017, and then there's a shoot and then a decline and then an upward rise during the COVID period, which is where the crypto talk also sort of boomed. And then you have the final time period of the prices, which is not predicted. This is the actual prices. And then now you see a correlation between the analysis that I conducted and how closely correlated it is to the actual price. And this is, so now you've understood that there's this analysis that is pretty accurate. There's metrics that I will be talking about in a bit. Now, what can you do? How can you predict the next set of prices? Because if I'm someone who wants to invest in Bitcoin, when do I know I should invest, right? That's based on the public sentiment. So this helps us understand the last 15 days and then predicts the next 30 days. So you have a 30-day period to understand if you would love to invest. And this is the entire plot of the closing stock price with the prediction, as you can see. So the validation and training metrics are as follows. So you have a 0.88 precision and a 0.85 accuracy. And some of the other metrics also involve the recall and the precision metrics, which have significantly shown a positive trend. And then, of course, these model evaluation techniques help us understand how useful using an LSTM was, which drives the point of it capturing sequential data's volatility. And these are the scores. So what conclusion do we arrive at, right? The fact that there's an effectiveness that's obviously been established through rigorous data analysis, and you're able to predict data 30 days from a current date, right? That shows the importance and prevalence of sentiment analysis, the bias, and how it affects such prices. And also implementation of LSTMs to predict these prices proves to be actually successful. It's not just in theory, but we've also proven it. And that's based and backed by these metrics. So what are the future scopes? Currently, what we did use were only prices, but if we increase and expand the metadata to financial reports, to other news articles which support and have these metadata, you will get a robust data set, and that increases more chances of improving the research. And other than that, we can also improve by looking into other cryptocurrencies, maybe Dogecoin, Ethereum, and so on and so forth. Those who are into Web3 might know more, and understand how those can be also incorporated into such types of research. So these were the references, and I'm happy to answer any questions that you may have. Thank you.
Thank you so much, Harini. That was a great talk. So I will field questions. I myself had some, but then I'm happy to field
Yeah.
questions from the audience first.
Thanks. Thanks for a great talk, Harini. Uh, a question I had was in financial markets, and especially in crypto markets, there's often patterns like pump and dump and so on, right? Where somebody tries to drive the price up a lot by buying a lot,
Yep.
and they rely on the hype that is being built through social media to essentially make gains. So how does your approach actually work? So there's a cause effect relationship there. There's a very, very high, strong sentiment in one direction.
Right.
What do you think your approach would do there?
Right. So that was one of the points that I considered, because it's very easy to just have a set of people or a bot that promotes a certain type of cryptocurrency and that leads to financial loss. But then the fact that we're incorporating such a vast time period helps us negate or sort of nullify such trends, because you cannot have, or it hasn't been observed that there's a cryptocurrency that's been falsely promoted for over a period of 6 years, right? It might be at max of 6 to 12 months, which is what was observed. But since it's over a longer period of time, those kind of scams were sort of nullified, and that helped sort of prevent these cases from entering the results.
I see. That's interesting. So when you're predicting for the next 15 days, for example,
Yep.
don't you think such an approach could over or under correct then?
Sure. Yeah, that's where there's scope for improving the architectures that's used. Maybe having a hybrid approach, not just in LSTM, but maybe having a federated learning approach where you're using other architectures which can sort of cover this architecture's bottlenecks, or, as the point you mentioned, would help sort of prevent that.
Awesome. Thank you so much.
No worries.
Hey, Harini, amazing talk. Thank you so much for this presentation. I saw that you had some precision and recall and metrics over there. Can you? I thought this was a forecasting problem. So, what was the precision and recall that you were measuring?
We were measured. Yeah, I was measuring the predicted price versus the actual price and the performance of the LSTM model. So, how accurately is it predicting the prices? And that's the benchmark that we were targeting, right? So, if there is a certain price range for the actual prices that's already present in the form of data, what is my model predicting and how accurate it is, or how close to it, the actual values it is? That's what was the metrics measuring. It was about 89%. Sorry?
What was the definition of recall for you? Like, how did you measure recall?
I performed the same set of model performance testings that you have. And based on that, whatever scores I got, I benchmarked that over the standard LSTM structures with financial data and got it.
Thank you for the awesome presentation. So I have two questions. I'll ask the first one. Uh, you have showed multiple parameters based on which you are going to predict the stock price. For example, if you are taking X as a platform, the number of followers, the number of
Yes.
retweets, right? Now, there is some seriousness that should be associated with the person whom I'm following there, because, for example, a Hollywood movie star
Yep.
will be having the same number of followers as Elon Musk or Jeff Bezos, right? Now, both of them might be posting something about Bitcoin, right? So how does your model take into account how serious should I be taking the profile of that person? Because I know most of the people might still retweet what a Hollywood star posts, but I will not make my investment decisions, or that may not influence my investment decisions,
Fair.
as opposed to somebody who is a techie who is posting those. So is your model differentiating?
Right. That's a great question. Again, that's the reason why I looked into multiple features. So the data set that I used, the features that I extracted involved the user's profile information and other such details, right? So when there's someone who's not in the finance background, that is already being accounted for, and they're being ranked in that order of importance or relevance to the retweeting. So because we're having a lot of information on the metadata on the person's profile, not just with the number metrics, but also with what they're doing, what kind of work they've been involved with, and all sorts of data, that helps us understand, how much of an important contributing factor that person becomes to such influence, to such influences. Yeah.
Got it. Thank you. So my second question is on in the future state you mentioned about I'll be looking at financial reports in the
Yes.
future, right? So for example, if it comes to a stock, I'll be looking at PB, PE, debtor days, cash flows. But here you have nothing but price. And then probably one other metric which I can kind of think of is Anusha is talking about pump and dump. And 2021, the surge in NFTs, cryptocurrencies is all because of the liquidity in the market. So what other financial metrics are you kind of planning to consider there?
So I was actually, since it was an elective project, I did not have time, but I wanted to incorporate gold prices as well, because gold is another
Okay.
commodity that's being invested in a lot and things like that. And that whenever the price of gold goes up, the cryptocurrencies also sort of get affected.
Okay.
So I wanted to explore that feature and those sort of data metrics more, but I didn't have time back then, but I probably will after.
Cool. Yeah. Thank you.
No worries.
Thank you. And I think this has been a great talk and a great set of questions.